Alright, so in this problem, I have 4 to the power of x plus 6 to the power of x is equal to 9 to the power of x. So to solve this, I'm going to divide both sides by 4 to the power of x. So I get 4 to the power of x over 4 to the power of x plus 6 to the power of x over 4 to the power of x is equal to 9 to the power of x over 4 to the power of x. Now, 4 to the power of x and 4 to the power of x cancel out, so I get 1 plus 6 to the power of x over 4 to the power of x is equal to 9 to the power of x over 4 to the power of x. And if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So in this case, 6 to the power of x over 4 to the power of x is going to equal 6 over 4 to the power of x. And 9 to the power of x over 4 to the power of x is going to equal 9 over 4 to the power of x. Now I can simplify these fractions. So 6 over 4 is equal to 3 over 2. And 9 over 4 I'm going to rewrite as 3 squared over 2 squared. And I can actually use this property again for 3 squared over 2 squared. So that's going to equal 3 over 2 squared to the power of x. And if I have something in the form a to the power of m over a to the power of n, this is the same thing as a to the power of n to the power of m. So this can equal 1 plus 3 over 2 to the power of x, which is equal to 3 over 2 to the power of x to the power of 2. Now I'm going to let 3 over 2 to the power of x equal to the variable y. So I get 1 plus y is equal to y squared. And if I subtract y minus 1 on both sides, these 4 cancel out, and I get y squared minus y minus 1 is equal to 0. Now, to solve this equation, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get y is equal to negative of negative 1 plus or minus the square root of b squared minus 4ac. So negative 1 squared, which is 1, minus 4 times a, which is 1, times c, which is negative 1, all over 2a, so 2 times 1. Now this is equal to positive 1 plus or minus square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So y is equal to 1 plus or minus the square root of 5 over 2. However, we're not done yet because we're not solving for y, we're solving for x. And remember how we let 3 over 2 to the power of x equal to y. So this gives me two equations. I have 3 over 2 to the power of x is equal to 1 plus the square root of 5 over 2, as well as 3 over 2 to the power of x is equal to 1 minus the square root of 5 over 2. Now to actually start, we can already cancel out one of these equations, which is the right-hand one, because 1 minus the square root of 5 is going to be a negative number, and you can't take the power of a positive number and make it equal a negative number. So this equation wouldn't even work. So the only equation I have left is 3 over 2 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So I have log 3 over 2 to the power of x is equal to log 1 plus the square root of 5 over 2. So now this turns into x times log 3 over 2 is equal to log 1 plus the square root of 5 over 2. And now if I divide both sides by log 3 over 2, I get x is equal to log 1 plus the square root of 5 over 2 over log 3 over 2. Alright, so in this problem, I have 3 to the power of x plus 3 to the power of x is equal to 12. So, obviously, I want to find the value of x here. So for my solution, I'm going to first start by rewriting my equation here. So I get 3 to the power of x plus 3 to the power of x is equal to 12. And now, on my left-hand side, I'm going to go ahead and factor out 3 to the power of x. So now I get 3 to the power of x times 1 plus 1 is equal to 12. And 1 plus 1, that's equal to 2. So I get 3 to the power of x times 2 is equal to 12. Now from here, I'm going to divide both sides by 2. So then these two cancel out, and I get 3 to the power of x is equal to 6. Now, if we plug in x equals 1, we get 3 to the power of 1, which is equal to 3. And if we plug in x equals 2, we get 3 to the power of 2, which is equal to 9. So we know that the value of x has to be somewhere in between 1 and 2, because 6 is between 3 and 9, meaning that x is going to be a decimal value. So, to find the exact value of x, we're going to have to use logarithms. So if I take the log on both sides, I get log 3 to the power of x is equal to log 6. And there are actually 3 important logarithmic properties that you guys should know. So the first one is that if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. The second one that you guys should know is that if I have something in the form log of a times b, this is going to equal log a plus log b. And finally, if I have something in the form log of a over b, this is going to equal log a minus log b. So we have log 3 to the power of x equals log 6, and we can use our first property here, log a to the power of b is equal to b times log a. So I can move x to the front, and I get x times log 3 is equal to log 6. Now from here, we want to isolate x, so I can divide both sides by log 3. So then these two cancel out, and I get x is equal to log 6 over log 3. Now, I'm going to rewrite 6 as 3 times 2. So I get log 3 times 2 over log 3. And remember, now we can use our second property, log a times b is equal to log a plus log b. So log 3 times 2, that's going to equal log of 3 plus log 2. And I have this over log 3. I can rewrite this as log 3 over log 3 plus log 2 over log 3. Now, log 3 and log 3, these two cancel out, so I get x is equal to 1 plus log 3, or log 2 over log 3. And log 2, that's equal to 0.301, And now I have this over 0.4771. So this is going to equal 1 plus 0.6309. And 1 plus 0.6309 is 1.6309. So this is my answer. Now I actually have a second method of solving this problem. So my equation was 3 to the power of x plus 3 to the power of x is equal to 12. And I'm going to start, like I started with the first method, by factoring out 3 to the power of x for my left-hand side. So I get 3 to the power of x times 1 plus 1 is equal to 12. Now, again, I'm going to solve what's in my parentheses. 1 plus 1 is 2. So I get 3 to the power of x times 2 is equal to 12. And again, I'm going to divide both sides by 2. So I get 3 to the power of x is equal to 6. Now, remember from I got x is equal to 1.6309. Now I'm going to plug this in. To my 4x. So I get 3 to the power of 1.6309 plus 3 to the power of 1.6309 is equal to 12. And 3 to the power of 1.6309 is 5.9998. And if I add these two together, I get approximately 12. So I get 12 equals 12, and because this is right, I know my solution is right.